Example 18, second last example for this whole chapter. A tennis ball is thrown upward from the top of a building with a velocity of 15 meters per second at an angle 30 degrees to the horizontal. The height of the building is 40 meters. Calculate the maximum height of the ball from the ground, the magnitude of the velocity of the ball just before it strikes the ground. Okay, so let's try and draw this. Okay, so there's a building. This is the building, and then the ball is thrown upward from the building, top of the building, at an angle of 30 degree. Okay, 30 degree. So theta is equal to 30 degree. This one is u, which is 15 meter per second. Okay, so if we were to draw the projectile there, it would be betul kah juga nih, begini, something like this lah dia punya motion, dia punya journey. Okay, so the bottom is our horizontal displacement, so the ball would end up somewhere here. Okay, so we are looking for V juga before it strikes the ground. Okay, so what information do we have? The height of the building is equal to 40 meter. Sorry, my cat is on my iPad. Okay, so this is 40 meter. And then we have to find the maximum height, which is from the ground, so which is this one lah. Maximum height berapa? So we know that, what do we know? We know at maximum height, velocity is equal to 0. And then what else do we know? We know that the acceleration at y is negative gravitational acceleration. Acceleration at the horizontal component is equal to 0. Okay, so from here we can then find the value for, ataupun the expression for uy here, and then ux. Okay, alright, so now ux is then equal to u cos theta, and then uy is equal to u sin theta. Okay, now we can find the maximum height. So how do we do that? Is by, hey, where is it? Oh, here. Okay, wait, oh, not okay, second last example pula ni. Okay, so we are looking for maximum height, so we can actually find using the formula v square u square plus 2as. Okay, but the s here is only up till, let me, okay, copy and then paste it here. Okay, so let's assume this is a diagram. So we are looking for the maximum height, right? But we can find up till this point. Okay, so let's label this as sy. Okay, so now we can find the maximum height from the top of the building below. Okay, so vy square equal to uy square plus 2gy pula 2ay sy. Okay, So remember, velocity is equal to 0 at maximum height. Lepas tu uy is u sine theta plus 2 negative 9.81 sy. Okay, so rearrange and calculate. You will then get the maximum height from the top of the building to be 2.87 meter. Hence, the maximum height is equal to sy plus dengan 40, which is h, height of the building. Okay, so then you'll get 42.9 meter to be the maximum height from the ground. Okay. Alright, next, find the magnitude of the velocity just before it strikes the ground. Okay, for that one, be here. So just before it hits the ground, we know we have to find x component and y component lah untuk velocity dia. In which case, let me just draw. Use this lah. So we have vy and then vx. Okay, so we have to find that component. And we know that vx would be equal to ux, which is equal to u cos theta. Why? Because acceleration at x is equal to 0. So you'll then get ux, or just write vx to be 13 meter per second. 13 meter per second is your velocity at x component. And then you have to find for vy pula. And you know vy, we can find it using the formula uy square plus 2ay sy. Okay, so uy is u sine 30 degree, which is our theta, square it to negative 9.81. Then we have our sy yang kita sudah calculate just now. The sy we are using, this one is our h. Okay, so this one would be our height of the building. Okay, this is our height of the building. So why are we using that is because we are looking just before it strikes the ground, so this distance lah, this displacement. Oops. Okay, so rearrange, substitute, and then you'll get vy to be 29 meter per second. So the magnitude is v equal to vx square plus vy square. Okay, so substitute that into the formula, the values into the formula, you'll then get 31.8 meter per second to be the magnitude of the velocity of the ball just before it strikes the ground. Okay. Alright, so that is example 18. Alright, last example for chapter 2. A transport plane is traveling at a constant velocity of 50 meter per second at an altitude of 300 meter, releases a parcel at a parcel when directly above a point X on level ground. Calculate the flight time of the parcel, the velocity of impact of the parcel, as well as the distance from X to the point of impact. Okay, now we know that the plane's velocity, which is equal to 50 meter per second, would also be equal to the parcel's velocity lah. Yalah, the parcel kan dalam aeroplane dia. Macam mana pula dia boleh lagi laju? Okay, so in that case, we know that the ux, which is the horizontal component, which is equal to 50 meter per second, whereas uy is equal to 0 meter per second. See, tiada di sini, u di sini. Kalau ni 90 degree, maksudnya dia kosong. Okay, so the vertical displacement given is negative 300. Why negative? Because they are going downwards. Okay, so the flight time of the parcel is then sy uyt minus half gt square. Okay, so sy here we can substitute negative 300, uy is 50, t is the what we are looking for. However, uy is equal to 0, sorry, just not supposed to be 0, minus half 9.81 t square. Okay, so calculate that, you will then get t to be equal to 7.82 seconds. Okay, next, the velocity of impact of the parcel. Okay, so we know that this is the velocity of the parcel, and then this is vy, and then this is vx. Okay, so we have to find each component x and y, and we know that vx would all equal to ux, which is equal to 50 meter per second. And then vertical component vy can be calculated using this formula. Okay, so uy is 0, 9.81, t is 7.82 seconds. You'll then get the y component to be negative 76.7 meter per second. Okay, it doesn't end there. You then have to find the magnitude, which is v equal to square root of vx vx square plus vy square. Substitute the values, then you'll get the magnitude to be 91.6 meter per second. Okay, so the velocity is a vector, so we have to have the magnitude as well as the direction. So direction is shift tangent vy over vx. Substitute that, you'll get negative 56.9 degree. Okay, alright, lepas tu we have to find the distance from point x to the point of impact, which is this one here. We know that we can actually find displacement for x component using this formula. Okay, why, dari mana ni formula ni? Dari mana? It is from this one. G pula. Plus half at square. But for x component, we know that a is equal to 0. Jadi dia tinggal lagi sx equal to uxt. Okay? Okay, so substitute the values, 50, 7.82, then calculate it, you'll get 391 meter as the distance from point X to the point of impact. Alright, so that is our example 19. And this is our last example for the whole chapter 2. Okay. Bye. See you on the next chapter.